Hi everyone. Notes 5.4 are on proving trigonometric identities. This is the first day of 2 days of this topic. So just a reminder that cosecant of x is it's always going to be 1 over sine of x, and secant of x is 1 over cosine of x. Okay? This next one, I don't know why it's here. We don't need this right here. So we know that tangent of x in terms of sine and cosine is going to be sine of x over cosine of x. And we know that cotangent of x is cosine of x over sine of x. Okay? Now, our Pythagorean identities, we already talked about that in video 5.1, so I'm not going to spend the time actually going over all of this stuff. So just a reminder that sine squared theta plus cosine squared theta is equal to 1, or we could say cosine squared theta plus sine squared theta equals 1. It doesn't matter what order you do it in. And if you look back to what we had for our other two identities, those are the other two that we need, and then we can rearrange any of these identities that we want. So let's derive them one more time, just to be 100% sure you're okay with it. Technically, you only have to memorize these ones, and you can derive the remaining ones on your own. So if I have sine squared theta plus cosine squared theta equals 1, if I were to divide everything by cosine squared theta, right here, sine squared theta over cosine squared theta is tan squared theta. Cosine squared theta over cosine squared theta is 1, and 1 over cosine squared theta is secant squared theta. So this right here ends up being tan squared theta plus 1 is equal to secant squared theta. That's one of our identities. And then the other one, I can take sine squared theta plus cosine squared theta equals 1 and divide everything out here by sine squared theta. So sine squared theta over sine squared theta is 1. Cosine squared theta over sine squared theta is cotan squared theta. And then 1 over sine squared theta here is cosecant squared theta. So we can also say 1 plus cotan squared theta is equal to cosecant squared theta. All right, so some suggestions when we are doing trigonometric identities. I strongly suggest that you change everything, change all ratios into sine and cosine. Okay, that's my first suggestion. My second suggestion is for you to try to use any double angle or compound angle formulas. And to be honest, it's not always going to be useful, but sometimes it will. Okay? All right, so let's go ahead and do example number 1 right here. So remember, if we want to prove something, we want to show both sides are the same. We can do a left side, right side, but what I'm going to do is I'm just going to deal with both sides until I get to a point where both sides are going to be exactly the same. Okay? So I want to prove that cosine of pi over 2 plus x is equal to negative sine of x. Okay? So since everything already is in terms of sine and cosine, I'm not going to rearrange any of that stuff. But if you notice right here, we have an addition formula right here. So we are going to use our addition formula right here, which we have right here for cosine of x plus y. Okay, so right here, what I'm going to do is I'm just going to say cosine of pi over 2 plus x is the same thing as cosine of pi over 2 cosine of x. So yes, cosine of x minus sine of pi over 2 sine of x. And that's going to equal negative sine x. Okay, because there's really nothing I want to do with this on this side quite yet, if at all. Okay, so now I'm going to evaluate all of this stuff. So cosine of pi over 2, when I look at it, at pi over 2 right here, I know the cosine is 0. so it's going to be 0 right here, times the cosine of x, minus sine of pi over 2 is 1 times the sine of x. And that's equal to negative sine of x. So now 0 times cosine of x is 0, and then negative 1 times sine of x is negative sine of x. So if I get to a point where my left side and my right sides are the same, I've shown both sides are equal, I've done my proof, and I'm done. That's my final answer. I've proven my identity, okay? Right, so taking a look at number 2, it says cosine of x minus y over cosine of x plus y equals 1 plus tan x tan y over 1 minus tan x tan y. So what I'm going to do for this is I'm going to rewrite cosine of x minus y using my compound angle formula. So I know that this numerator right here is going to be cosine of x cosine of y plus sine of x, sine of y, okay? And then I'm going to do the same thing for my denominator here. Cosine of x plus y is going to be cosine of x, cosine of y, minus sine of x, sine of y, okay? And that's going to equal, on the other side right here, I have 1 plus tan x tan y. So I'm going to convert everything here into sines and cosines. So in my numerator here, I get 1 plus sine x over cosine x times sine y over cosine y, okay? And then in my denominator right here, I'm going to get 1 minus sine x cosine x times sine y cosine y. So now that I've done that, I'm going to rewrite this right here as 1 plus, I'm going to make this one single fraction. So multiply your numerators together, sine x, sine y. Multiply your denominators together, cosine x, cosine y. Okay? And then in the denominator here, I'm going to have 1 minus, multiply your numerators together, sine x, sine y. And then multiply your denominators together, cosine x, cosine y. Okay? Then what I'm going to do here is I'm going to make this so I don't have fractions within fractions, so I don't have complex fractions. So I'm going to multiply by my common denominator. So if I take a look at what I have here, sorry about that, my common denominator is cosine x, cosine y. So I'm going to multiply by cosine x, cosine y over cosine x, cosine y. Okay, and when I do that, 1 times cosine x cosine y ends up being cosine x cosine y. And then here, this cosine x cosine y and this cosine x cosine y would cancel each other out, right? So I end up getting just sine x sine y. Okay, all over, and then in my denominator here, when I distribute the cosine x cosine y by the 1 here, I get cosine x cosine y minus this cosine x cosine y, and this will cancel each other out, so I end up getting sine x sine y. And that's exactly what this left side here says. So I end up getting on this side cosine x cosine y plus sine x sine y. I'm literally just copying this down, all over cosine x cosine y minus sine x sine y. And then I'm just going to put an arrow to bring this down. You don't have to copy it down every single time, but when you get to a point where you're ready to work with one side, then you can just draw an arrow down, okay? And then right here, we've proven our identity because we got to a point where both sides are exactly the same, and we're good to go for that question, okay? Before we look at number 3, I just want to give you one more suggestion. Right here. So if you guys look right here, we have our list of suggestions right here. My last suggestion that I have for you is to factor, because any type of factoring will help you out when we're trying to do this kind of stuff, because when we factor it, we're able to simplify our expressions, and then we can get to a point where we've got both sides being equal to each other. So on that note, if you take a look at what we have here, we've got tan 2x minus 2 tan 2x sine squared x is equal to sine of 2x, okay? So if you guys notice right here, when I do this side over here, I can see that I've got tan of 2x in both terms, so that's my common factor. So I can factor out a tan of 2x, and when I do that, here I have a 1 left over, and here I've got minus 2 sine squared x. And then I'm just going to copy down this sine 2x on this side, okay? Now, tangent is always sine over cosine, and we said that we always want to write our information out in terms of sine and cosine. So I can say tan of 2x is sine of 2x over cosine of 2x. Not only that, but I can also say 1 minus 2 sine squared x. If you take a look at what we have right here, we know that 1 minus 2 sine squared x is equal to cosine of 2x, which is very convenient. So right here, we can say this is times cosine of 2x over 1. I just replace the 1 minus 2 sine squared x with cosine 2x. Then I'm just going to copy down the sine 2x, okay? So then lastly, if you notice right here, the cosine 2x and the cosine 2x will cancel each other out. So I end up getting sine 2x is equal to sine of 2x. Done, proven. I've proven that both sides are equal to each other, so my identity holds true. Okay? These questions have the potential to get really tricky, so although the examples that I gave you here are just some basic examples, you really need to make sure you get the practice with some harder examples and ask me questions to be 100% sure you're okay with this topic. All right, that's it. I hope you have a great day, and I will see you next time we have class. Bye.